Hello everyone, this is your tutor AB. Today we're going to be solving a problem from the November 2023 IB Mathematics AHL Paper 1. This is a 6-mark question. Let's get started. The binomial expansion of 1 plus kx whole to the power of n is given by this expression right here, 1 plus 12x plus 28 k square x square plus at the end k to the power of n x to the power of n. So just like a general equation they've given. And find the value of n and the value of k. Okay, so that's the whole 6 marks. How do we get started? Well, let's expand this. Let's just expand it to the first 3 terms. That's all we really need here because that's all we're really given. So how do we expand 1 plus kx whole to the power of n? Well, we know we can say first n choose 0 times by 1 to the power of n times kx to the power of 0. Now this formula is given in your data booklet. They're given n choose 1 is of course 1 to the power of n minus 1 kx to the power of 1, and n choose 2 is 1 to the power of n minus 2 and kx whole square. Now we're only interested with these 2 terms right here, and I'll show you why. Because we can do a direct comparison. We know that this term right here is equal to 12x and this right here must be equal to 28 k square x square. Okay, so this is a direct comparison that we need to do. Okay, so let's do this first part. And choose 1 to the power of anything is just a 1, so we don't need to include that. And choose 1 of kx is equal to 12x. Now that's our first equation to deal with. How do we solve this? Well, we know n choose 1 or anything choose 1 is always itself. So for instance, n choose 1 will just be equal to n. 5 choose 1 for instance would be equal to 5. 6 choose 1 is 6. So n choose 1, anything choose 1 is always itself. So nkx is equal to 12x. So x and x cancel, so we get our first equation. Nk is equal to 12. Okay, now let's do the next part. We get n choose 2, again 1 to the power of anything is just 1, so we need not include it, times kx whole square. That's directly equal to 28 k square x square. Now we can cancel this both out, so we know that n choose 2 must be equal to 28. And why is that important? Well, I'll show you. What is the formula for a permutations combinations question? Well, it's in your data booklets and this is a combinations question. So the formula for combinations is n factorial over n minus r factorial times r factorial. That's the formula for combinations. So we'll apply that here. So we get n factorial over n minus 2 factorial times by 2 factorial, and that we know is equal to 28. Okay, so we get that n factorial over n minus 2 factorial. 2 factorial is just 2 and we cross multiply will be equal to 56. Now I'll start from here. So now what do? I can't really do anything in its current state, so I'll manipulate this factorial. What will I do? Well, n factorial is the same as saying n times n minus 1 times n minus 2 factorial, isn't it? That's the same thing. I just rewrote n factorial in a way that's more useful for me. N minus 2 factorial. This and this will go. So I'll be left with n times n minus 1 not factorial in this case, n times n minus 1 is equal to 56. Now let's distribute. N square minus n minus 56 is equal to 0. So let's solve this quadratic. Well, it will simply be n minus 8 to n plus minus 7. That's equal to 0, so n is equal to 8 or n is equal to negative 7. Let's go up here. Now what are we supposed to do? We need to find the value of n and k. Okay, so let's do this. We found out the value of nk earlier. Nk is equal to 12. So using this, I can solve this problem. Okay, and keep in mind that n must be a positive number. So this cannot work. N has to be equal to 8. See, that's where they'll trick you. N is z plus. It is part of z plus. So it's a positive number. Okay, so nk is equal to 12. And we know that n is equal to 8. So 8k is equal to 12. So k is equal to 12 by 8. Which if I simplify is equal to 3 over 2. Okay, thank you for watching. Please like and subscribe. If you have any questions, leave it down below. I'll answer it as soon as possible. Thank you for watching.